class, because if you have another exam on the same day, it's not considered conflict. It's conflict only if you have the exam at the same time. This time is given by the scheduling office. They look at the class, they say there's no conflict today. You may have an exam at another time today, but if we move the day, it's going to create conflict for some people. It's a seat assignment. Find your seat, find your name, and find your seat. The exam will be in Physics 112. Okay, any questions? So this is what I'm going to do. If you ask me questions, I will be happy to answer. If you don't ask me questions, I will start talking about how to read and write files. Okay? Is that clear? All right, so any questions? Yes, please.
Can you go over the fourth argument for Q-sort?
Go over the fourth argument for Q-sort? Okay. So, or you can take a... All right, so Q-sort. Let me show you how Q-sort works. Q-sort has 4 arguments. The arguments are... Oh, it's not working yet. Give me... Let me try to set it up. Okay. Okay, I guess that works now, right? Q-sort has 4 arguments. The first argument is the address for Q-sort sorted array. Well, let me find it first. Why is it so slow? Q-sort has 4 arguments. The first argument is the address of an array. Then the second argument is the size of the element. It should be in the string, I think. Let me go to it. So first, this is a class note. I encourage you to look at this. So Q-sort has 4 arguments. The first is the address of the array. The second is how many elements you have in the array. The third is what's the size of each element. And the fourth is a comparison function. Q-sort was written many years ago before the concept of class hierarchy was developed. So at that time, when Q-sort was developed, there was no concept of base class. So when Q-sort was developed, they want to make it general. The way to make it general is to use something called a void star. Void star means the following. Means it's an address, but it doesn't know what type it is. So this says it is an address. And you have to tell Q-sort what type it is. And the type is given by the size. The second argument is the number of elements. I'll go over this. And then the fourth argument is a function. The function has to return an integer. This parenthesis star means it is a function. It's the name of a function. Then this means the function has to take 2 arguments. Both of them are pointers. And you are not allowed to change the content through a pointer. Void star again simply means it's a pointer. It doesn't know what type it is. Okay, any questions so far? So let me draw a picture and show you the concept Q-sort, how it works. Q-sort sorts an array. So you have an array. You have an address. You have variable. And you give the address in C programs. When you have an array, it is guaranteed the memory space will be contiguous. So if you have an array the memory space will be next to each other. This will be the symbol. You give Q sort this address. So this address will be the first argument. For Q sort. And the second argument is how many elements you have. The third argument is what's the size of each element. Why do we need to do that? Because this is how Q sort works. Q sort will take the first argument as address. Let's call it address X. So address Q sort will take address X plus some value, let's say I, times your size of an element to get an address. What is I? I is greater than less than 0 and greater than less than the number of elements. So this is how Q sort works. You will take the I is controlled by Q sort. I told you about that in a moment. Then suppose I is a number, you will go to this address and read the value at that address. I does not change from 0, 1, 2, 3, 4, and so on. Q sort is called quick sort. Q sort is fast. It's called quick because the value I changes following the following properties called transitivity. Transitivity says if A is greater than B and B is greater than C, you know A is greater than C. So Q sort will choose two elements. Let's say it chooses element, this one element, and this element. You'll determine which one is larger. Now if you compare this one with this one and find out it has this property, you will not compare A and C because that's unnecessary. Okay. We'll talk about how Q sort is implemented in a later lecture, but that's the concept Q sort. You take the address, you need to tell how to calculate the address of each element by giving the size of the element. You tell Q sort how many elements they are. And Q sort will select some elements, not all of them. Some elements, some pairs of elements, and compare them. And also follow this property. However, since Q sort is general, it doesn't know how to compare elements. So you have to tell Q sort. As I said, Q sort is intended for any kind of array. So you have to tell Q sort how to compare two elements in the array. That's the fourth argument. Any question about this so far? I talked about how to write comparison function. So the way Q sort, the comparison function works is the following. Q sort is going to give you two addresses. In your comparison function, const means you are not allowed to change it through a pointer because you are allowed to only compare them. This is your comparison function. P1 is going to be an address of the array element. And P2 will be another address of the array element. Q sort will give that to you. You do not call your comparison function directly. your comparison function will be called by Q sort. So after you get P1 and P2, you have to specify how you want to compare the variable at that address. Because comparing addresses make no sense. Addresses are given by the operating system. Any questions so far? So when you get a P1 and P2, what you need to do is to first cast the type to an appropriate pointer. Suppose this is an array of integer, then P1 will be a pointer to an integer. So if the array is an array of integer, then P1 you will say const integer pointer you know it is an integer because you give an integer array when you call Q sort. So that gives you a pointer to an integer. Similarly, you'll create another pointer for P2. What this means is this one will be an address, this one will be an address. These addresses are given to you as the argument when Q sort calls the comparison function. Then what I'm going to do is you are going to change it to integer value then you get a value here, elements, because you want to compare the values. You don't want to compare the pointers. Comparing pointers make no sense, right? Then you can say if integer v1 is greater than integer v2, you return 1. If it's equal, you return 0. If it's less than, you return -1. Then based on this information, this comparison function tells Q sort how to compare two elements. Then Q sort will arrange the elements in an array so that it's sorted. I'll show you examples in a moment. First, I'll give you some time to think and write down your note. Any questions? As I said, for those people that come late, I have some chocolate. Yes, your question, go ahead.
What is the purpose of having a separate comparison function rather than having a Q sort kind of built in comparison?
Because Q sort cannot have comparison function. Oh, sorry. I go too far.
Because
Q sort does not know what is an array. It can be an array integer, it can be an array string, it can be an array of a character, it can be an array of double. Later when we talk about data types you build, it can be an array of the data types you build. Q sort has no idea how to compare. Let's say you build an array of students. You have created a student database. Are you going to compare by name, compare by ID, compare by year, compare by, you want to sort by department? Q sort does not know. You have to tell Q sort. That's the reason you need to have a comparison function. Is that your question?
Yes.
Okay. Yes?
The return has to be 0, 1, or negative 1.
It has to be, okay, let's go back to the document. See what the document says. The comparison function must return an integer less than equal to or greater than 0. It doesn't have to be 1 or -1, but it has to be positive, negative, positive, 0, or negative. Do you see that?
But according to what you wrote, it only returned 0, 1.
Yes, but my comparison function meets this requirement. The requirement is it has to be positive, 0, or negative. You can return true as long as it's positive. But I use 1. 1 meets this requirement, right? The requirement is it has to be less than, equal, or greater than 0 if the first argument is less than, equal to, or greater than the second. So my comparison function meets this requirement. Does that answer your question? Does that answer your question?
I don't get it.
The requirement it says it has to be positive, 0, or negative. I use 1 because 1 is positive. So I meet the requirement.
What about 0?
Equal to, it says less than, equal to, or greater than 0 if the first argument is less than, equal to, or greater than the second. Let me put it side by side, see whether you agree with me. The first argument is less than, the second, then it returns less than 0, right?
Oh.
Based on that statement. Do I meet that requirement here? Do you agree with me now? Yes.
How does Q sort of interpret 1 or the positive 0?
It compares to 0. Q sort, if you return 1, you will take the value you return and compare that with 0.
Oh,
So if you return 1, it's greater than 0. If you return 2, that's greater than 0. It's fine.
so if it returns negative, that means the value is less than?
Means the first value is less than the second.
Each comparison function only compare two addresses. How would the Q sort arrange all of the?
Because Q sort will call comparison function multiple times. Okay. Let me first show you an example of comparison function. Okay. This is a general structure of comparison function. You have to determine the type. The type is depends on what type you give. It can be integer, double, float, or later on when we talk about types you create, it can be the types you create. Yes, it means you are not allowed to change it inside the function. Okay. So it's constant means I only read the value. I can only read. I cannot write. That's what constant means. So first you will change to a type from void star. Void star simply says it's an address. So you don't know what to do with void star. You cannot compare void star and treat it as an integer. So let me go back to here. This one. Integer on most machines have 4 bytes. Double, if you use the standard, has 8 bytes. So if you say, I want to compare 2 elements, C program says, how big is one element? You have to tell me, how big is one element? Right? And you have to tell me how to compare them. Comparing integers, if you have taken, how many have you taken 270 or are taking 270? Okay, did they talk about floating point representation? Not yet. Okay. Integers or floating point numbers are represented differently inside computer. So if you don't tell computers how to compare, are you comparing integer or comparing floating point or maybe different types? Maybe the types you create. QSO doesn't know how to do. So you have to say how you compare them. That's what this typecast means. You tell the program how to interpret a type. The first one, like the line 3 and the 4, means you treat it as pointers. And the 9, 5, and the 6, it says take the pointer and get the values. Because pointer means addresses. It doesn't make sense to compare addresses. Yes?
But it doesn't really need to be a constant, or does it? Because in our example, we didn't use it.
You should use constant.
We just used
You should.
int value.
You don't have to,
Yeah.
but you should.
Okay.
And depends on where you miss the constant, sometimes you get compiler warnings. Constant simply says you are not allowed to change. You should add constant as much as you can to prevent accidentally change your values, because that happens often. Yes?
If, in that comparison function on the board, if we switch the return values to -1 and 1, will it sort in the other direction?
Yes. Oh, sorry. If you change this to, if you change line 8 to 1 and line 11 to -1, you will change in a descending order. Currently, you will change in an ascending order. So I think that's written there. Anyway, if you follow this rule, the sorting Q sort will sort in an ascending order. If you switch this make line 8 return 1 and line 11 returns -1, you will sort by the descending order. Yes?
So we have given one argument to as two variables, right, which are pointers.
Yes.
And then we are taking access saving it into pointer 1, pointer 2.
Yes.
Can you directly extract the values from this?
No, you cannot because you don't have a type. Let me show you this is a concept. Let me show you a specific example for integer. Is there a question over there? Go ahead. Okay, this is an example of integer. The earlier one is a general concept when the type can be whatever type. This is an example of integer. So you change the type to integer. Then PTR1 is a pointer to an integer, PTR2 is a pointer to an integer, and value 1, value 2 are integers. Then you can compare them.
Can you put an asterisk in front of argument 1 with the type casting and make it an integer type argument?
You can, but I suggest you do this way because it's more clear. Do one thing at a time. Don't take shortcut. Take shortcut, increase chance of mistakes. Yes?
When you're sending the fourth argument to record,
Okay?
you just send the function name or you send ampersand and then function name?
You send the function name because function name itself is a pointer in C. So let me show you how to code Q sort. Okay, so from function name it's called comparison function, right? When you call Q sort, you give comparison function. So this is how you call Q sort. You give the address of first element, give how many elements you have, and the third argument is the size of each element, and the fourth argument is the name of function without ampersand. Yes?
Can you scroll back up?
Sure. Where? This one?
Yeah.
Okay.
Like for line 11 and 12, why do you have to create a new constant?
Because I want to make it clear. Sorry. I want to make it clear. I want to take one step each time. So in the comparison function, you need to do three things. You need to first pass the type into the type you know. That's line 11 and 12. Second, you need to get the value at that address. That's line 13 and 14. And then from value, you need to compare them. That's line 16 to 18. You need to do three things. I want to make it clear you need to do three things. Does that make sense? Now, if you want to, actually, some people would just compress all three things in a single step. That increases the chance of mistakes. So I think it's better to take one step each time. Does that answer your question?
Yeah.
Any more questions? I will show. Excuse me. I will show you an example, and this is in the class note. So in a comparison function, I actually print which values are being compared. On line 15, it prints which values are being compared. If you scroll down, suppose this is your input array. You will first compare the first two numbers. How does it compare the first two numbers? Because you take the best address, and then take the best address plus size of each element. So compare two numbers. Then compare another two numbers notice that this time it compares the third and the fourth. And the next time you will compare the second and the fourth. It's jumping. Why is it jumping? Because it starts building the order based on the property of transitivity. If you read this, I'm not going to read this line by line for you. If you read this, you'll find the first case. In both cases, you have A numbers. You have A numbers here, and you have A numbers here. In the first case, you'll compare 16 times. So comparison function is called 16 times, right, from 2 to 17. In the second case, the comparison function is called only 13 times, from actually 14 times. Why is that? Because the transitivity, once it knows the order of two numbers, you will not code again. So I encourage you to read this to understand more details. Did I answer your question?
Yep.
Okay, any more? Is QSOR clear, or do you need more information? Yes?
Can I scroll a little bit?
Oh,
Yeah.
okay.
Uh,
More?
So yeah, when to the sort function, to the Q sort. So when you send the array, you send the first address of the
Yes.
right?
Yes.
But then how does the function know that it goes to the next one, to the next like how does it know what that?
Because the second argument says how many elements you have in an array. The third argument says how big one element is. So QSOR knows what's the size of memory the whole array occupies. Does that make sense?
Yeah, but how does it know the address of the second one?
Because the address, because
the
in,
address is different.
all right, so your question is, how does QSOR know the address of a second element or third? In C language, if an array, if you are dealing with an array, it is guaranteed addresses are contiguous. So the address for the second element is the address for the first element plus the size of an element. So the address of an array, any type of array, is going to be the address of the first element plus I times size of each element. Does that answer your question?
Yeah.
Now I'm going to scroll down a little bit more. Are you done with this? Need more time? Yes?
Like if in the declaration I declare an array, and can I use a pointer form to call this array?
Yeah, pointer and array array has to be a pointer. We talked about that before. Okay, I'm running out of chocolate, so if you want to get chocolate, you better ask questions soon. Okay, so let me show you more in the handout. There's an example of sorting a string. Now, string itself is going to be character star, right? Each string is character star. So you simply think about this as integer. A way to think about string is you imagine C has a type of string. And since if a string is a type, it will be similar to int. So you replace every place int by string. Then you replace string by character star. Then the rest will be the same. Maybe I should write it down. So how to deal with string? You imagine that C has the string type.
It's too high.
Okay. Then any place you say string, since string is a type, is equivalent to integer. But string is, C doesn't have string type, so if you say string, you say character star. Yes.
Can we just type def character star to be a string?
Yes. But you have to do that. Okay. So if you compare this, you compare this character star, and you go up to the previous function for integer, it's simply taking integer, replace that by character star. Yes.
Can you explain a little bit what's happening on the left side of the equation?
You mean this one or next one?
The next one.
Okay.
Because there's. Yeah.
Okay. You mean a const? Is that what you ask?
Yeah, well, there's two cons, right? That's.
Okay. So that const has two meanings. If it's before the type, means you cannot change the data through a pointer. If after the type, in this case, you cannot change the pointer. Let me draw a picture, explain. So we have a pointer, right? Suppose you have a pointer. You have symbol, you have address, you have variable, and of course you cannot change your address, right? So let me say the address is 100. Since it's a pointer, the variable is an address, right? So let me assume the address is 200. So that means 200, there's some variable here. Okay, so if you put the const in front, that means you cannot, let's say, you can const specify which you cannot change. One is you cannot change this one is you cannot change that one.
In this case, we can't change both.
In this case, you cannot change either.
Oh, okay.
Means you cannot change this variable, and you cannot use variable to change that one.
Yeah,
Okay. And in the class note, I also explained, I have some examples here, section 6. So this is an example where you have, oh, you don't see. So PTR1 has const in front. PTR in front CHAR. PTR2 has const after CHAR. So in this case, PTR1 variable can be changed, but you cannot change PTR1. Use PTR1 to change the variable there. Let me draw the picture here. Maybe I put it. So when you say const, I use character star. It has its address, it has a variable, let's say 200. When you do this, means you cannot change this one. But you can change this one. You can change, cannot change. Can change. You can say, I want the pointer to point to somewhere else. I can change it to another location.
Can we free the memory in this case?
What?
Can we free the memory?
Do you use malloc? You answer the question? Okay, malloc and free are next to each other. They have to come together. So in this case, look at line 8, no, line 10. You cannot change the variable through this pointer. Now line 12, no, line 9 says PTR2. So this is PTR2. Let's say it's 120. So suppose this is address 300. PTR2 means you cannot change this one. You cannot change the variable PTR2, but you are allowed to use PTR2 to change the variable at that location. Does that answer your question? Okay, any other questions? Yes, please.
Do you have the summer 2013 exam?
Sure, just give people a little bit more time. Any more questions about this? Any more questions about Q-sort and const and typecast? So to summarize, you should add const whenever you think you do not intend to change, because that reduces the possibility of mistakes. Every time you write something, you say, I don't want to change, I don't intend to change, put const there. Because later on, if you accidentally change, you write something, and you may change it, compiler will tell you. And that, again, that's a good thing, right? Okay. Any more questions about this? All right, so let's see, which one? Summer?
Yeah.
2013? Which exam?
The first one.
First one. Which question?
Just the recursive trace on
Number 3, okay. So first let me read the question. Oh, another thing is, I want to remind everybody, in every exam you need to sign. If you do not sign, you will lose 2 points. Okay. Don't come to me and say, I do not know. Okay, everybody here is witness, right? And it's recorded. For those people, they are not in today's class. If they come to me and say, I do not know, what should I say?
Come to class.
Come to class. Okay, does everybody agree? I have told you. Does everybody agree? Anybody sleeping? Raise your hand if you are sleeping right now. Okay, so I will tell you again. You need to sign your name in the exam. Is that okay?
Yeah.
Okay. Every single exam you need to sign your name, okay? It surprised me in exam 3 or exam 4, people still don't sign their name, and we take 2 points out. Okay, so make sure you understand.
Open book.
Open book, open no exam. Anything on paper is allowed, nothing electronic. No calculator, no iPad, iPhone, Android, Galaxy, okay, laptop. Okay, why are you laughing? Okay. Oh, another suggestion. I know everybody study very hard. Take a nap before the exam. Because if you fall into sleep during the exam, what should I do? What should I do? It's not happened before. Okay. So don't fall into sleep during the exam. All right. Exam 3. Question 3. Trace recursive function. Consider the following program. You have function f. It has 2 arguments, integer and a pointer. Once you enter the function, the first thing you do is to increment some. Oh, I should show it here. I should show this in a tape, in the recording. Okay. So remember to sign your name, otherwise you lose 2 points. Whoever watching the video. Okay. And inside the function, line 6 says if a is 0 or 1, return 1. The function does not call itself anymore. Otherwise, it goes through a loop of 0 to n and call fi or fn minus I minus 1 and sum. And variable is a times b, return variable. Excuse me? sum is addressed here on line 25. Is that your question? Okay. So everybody understand what's going on here? Okay. So I'm going to tell you, one way to solve this problem is to draw code stack. And some people do. But I'm going to tell you another way to solve the problem. You draw the coding tree, yes. So you are going to call the function f3. Right, that's what the line 25 does. VAL is 3. So you go to line n is not 1, it's not 0, so you will go through a recursive function. And then you have a loop here, so I will be 0, 1, or 2. Why is 1, 2, 1, 0, 1, 2? Because it has to be less than 3. Does it make sense for you so far? N is not 0, it's not 1. So the function does not stop at line 8. Then the function will go to line 12 and go through the loop. Goes to 0, 1, and 2. Okay? When I is 0, you are going to call A equal to F 0. And B is going to be F. N is 3. I is 0. So this will be 2. And when I is 1, A is F1, B is F2. I mean F1, sorry. 3 minus 1 minus 1, yeah. When I is 2, A is F2, B is F0. Does this make sense so far? When I is 0, inside the for loop, you need to call F0 and F2. Okay, so F0, you will call the function, you will return 1. But you will still call F0, right? F2 is not 0 and 1, so it will be I equal to 0 and 1. Is everybody with me? And I is 0, when I is 0, you will call the function A equal to F0 and B equal to F. So 2 minus 0 minus 1 is 1. When I is 1, you call F equal to and B equal to F0. And this will return 1. This will return 1. This will return 1. This will return 1. So what's F2? F2 take, this will return 1 and 1. So when this one val is going to be A times B, so it will be 1. And here,
Why did you not calculate val in the left side? I mean, in the I.
we can do that too, but I don't have a B, so I cannot calculate. You mean this? You mean this one?
Okay. I'm sorry.
I don't have a B,
Yeah.
so I cannot calculate val here.
No.
Does that answer your question? Yes, you have a
So the
question.
return of that mess is going to be B, right?
Say that again.
The return of that whole part is going to be B, right? And then you can
This
multiply
one-
A times B.
This will B becomes 1.
No, for the B above that.
This one,
Yeah.
I'm not done yet. I need to finish this part, then I can get the B. Does that make sense?
Yep.
Okay. So val is 1, and this 1 is 1, so A times B is 1, and then val plus 1. So here val is going to be 2. So b will be 2. Then val plus 2, so val is 2 right now. And then you follow this procedure. Then you can calculate what the val will be. And you can calculate how many times the function is called. Because sum, on line 5, every time the function is called, you increment the counter. Sum is an address, the address of the value at the line 23. If you look at line 23, you get the address. So line 5 means the following, in case you are not comfortable with the syntax. When you write this, it means the following. You get a temporary equal to sum. You increment. You write it back. That's what this line means, the 3 lines.
Is that 5? I mean,
That's line 5, yes. Line 5 does the following
space
3
doesn't
things.
make any difference, right?
Space makes no difference.
Okay.
Be careful, some people would write this way. You'll get compiler warning. Because without parentheses, plus go first. So this means it's doing this. And what that means is you take t equal to sum,
Address.
t equal to t plus 1. Now this t is address. This t are different types. This t is a pointer now. And you read. But you're not storing anywhere. So you read the value, you're not storing anywhere. That's where you get a compiler warning. This is similar to the following. You just read the value A, you're not storing anywhere. So compiler will say, you're probably making a mistake. So with parentheses, without parentheses are different. With parentheses means you are incrementing the value at the address 23. Because that's the address of a sum where you pass that in the second argument on line 25. So go back to this figure. Every time you call f, your sum will increment. Does that answer your question? Okay. You could draw a call stack. Some people actually did, but that will take a lot more space.
Yeah.
Yes.
So the number of times it ran on like that side that you had is 6 times? 'Cause
So on this side, you will say sum equal to 1, 2, 3, 4, 5, 6. Yes. Then you add this part, and then you add this part, then you add itself. Remember, don't forget itself.
Oh, and then the value, you just like, it'd be 2 times 1, 8 times.
I think 2 plus 1
Oh, okay.
plus 2 will be 5. Do you get 5? Does anybody get 5? Okay.
4. To the right, a equals to f2. So after that, you call the f function twice, right?
So this one will be symmetric to that one, right? So f2, this will become 0 or 1, and this will be a equal to f0, b equal to f1, and a equal to f1, b equal to f0. And then this one just return 1. Right? It's basically symmetric case. Does that make sense? Okay. Yes?
Project the screen.
Oh. Any more questions? You have a question?
Can you show how to do it using a call stack?
Call stack is a lot more work, so I encourage you
So,
to.
like, do you
I
think
encourage
it'd
you to
be-
do this way.
Would it be better to do this way for any recursion?
The problem with recursion is your call stack. I'm sorry. Do you mean using call stack? The problem using call stack grows and string grows and string, so it's easy to make mistakes.
Do you have an example where you would use a call stack, like where it would be a better idea?
In a class note, I show an example actually. Let me see where it is.
Is it 5, you said? 5 or 4?
5.
And what will be the sum?
Let me see whether I have that here. I think I have it somewhere here. Yeah, so this is an example of using call stacks. If you trace this example on section 10.1, then you'll see the call stack grows and shrink. Yes.
But so to that last problem, what is the final answer? Is sum equal to 6 and FU is 0 or 1?
Sum is not 6. So let me count. It's 15.
You just count how many times.
How many times f is called? How many times f is called? That's what the sum gives you. And the value is 5.
5? Oh, the value is
Value is 5.
Oh, okay. Can you explain why programmers use recursion? Is it something more efficient or some?
Because some problems are much harder to solve without recursion. We'll see examples. After the exam, we started looking at many examples. Some problems are very naturally solved by using recursion. Those problems are usually the problems you do not know how many iterations you have. And in that case, recursion becomes easier in many problems. We used to talk about recursion at the beginning of the semester because for some mysterious reasons, many students are very afraid of recursion. That's the feedback I got from students. Some students say, if you teach me the content without using the word recursion, I will learn it. Once you mention the word recursion, I give up. Even I don't know what it is, I just give up. I don't know why. But this semester, we decided to talk about recursion a little bit later, because you really have to understand call stack very clearly if you want to understand recursion. And the problem of many students, they don't understand recursion because they don't understand call stack. If you understand call stack fully, recursion is nothing magic. At least in terms of writing the program. In terms of using recursion to solve problems, we'll see many examples where recursion becomes very natural in developing your solution. So if you want to see how the call stack grows and shrinks, look at that section 10.1 over there. When the exam was given, actually a few students actually use call stack to draw, and they show me it's more work because it keeps changing. Yes, you have a question. Go ahead. I cannot hear you.
If we didn't learn about recursion yet, so then what is the content of the statue?
The content is you can change the C program.
So it's just going to be like section 3.
Yeah, something like that. We will not ask you to write a recursive function, but we may ask you to trace a recursive function. Does that make sense? So if you already know how a function works, how call stack works, then you should be able to trace the example I just gave you. Does that make sense? Okay. I thought another hand. Yes, go ahead. I don't think I gave you trophy yet. Okay. What's your question?
Can you go over number 1 of spring 2013?
Number 1, spring 2013. Okay. Let's see. What did you say? What did you say? Spring 2013.
笔记往加一个。
Let's see. Okay.
Are you going to ask about scopes like this integer? I mean, this variable is
Recursive. Okay. Some of the functions you may not be ready to do that yet. For this one, this question is not in this exam. But 1.2 maybe.
So which questions do we have to know from the exams you posted then?
Okay, 1.2, because it's a function. If we ask you to write a recursive function, that's out of scope of this exam. But if we give you a recursive function and ask you what it does, that's within the scope of this exam. Does that make sense? If we give you the program, ask you what the program does, that's within the scope of this exam. So in this case, consider this program and ask you what this program does. That's within the scope of this exam. Do you want me to go over this?
Well, yes, but then is the question about permutations, could that be a thing?
That will not be in the scope of this exam.
So if you have to like modify and like write code, then that would not be on there.
Correct. We will not ask you to write recursive code, but we may give you recursive code and ask you what the program does.
How about ask you to modify it?
No.
Could you walk through the tracing? Then?
Sure. Okay. So first, let's read the program. Again, please read the questions before you answer the questions. I don't know how many times I have to answer that, but every single time I see students answer wrong questions. So first, the function has integer, n, max, sum, depth, 4 arguments. And there's an integer local variable f1, f2, sum. And the comment says the sum is the summation of fn minus 1 plus fn minus 2. And sum increment. So that says how many times the function f is called, because it increments before it does anything else, before the if statement. Then if max is less than depth, the max becomes depth. We'll look at the depth in a moment. Then if the first argument is 0 or 1, it returns 1. That's a terminating condition for recursion. Means the function will not call itself anymore. If a is not 0 and a is not 1, you will call fn minus 1 and fn minus 2. You'll give max and sum and depth plus 1. So the concept is you have a recursive call, and recursive call, and recursive call. And the depth says how far you go. Does that make sense? Every time you call a recursive function, depth increment by 1. So at the end, max says how far you go. And sum says how many times you call. And then line 19, add these two numbers together. So let's see how we solve this problem. We call this function using 6 on line 28. And max and sum are both initialized to 0. So we'll call f 6. Six not 0 and not 1. Then we'll call f5 and f4.
Push it down a bit.
Oh, sure. Why do I only write 6 and 5 and 4? Because n is a controlling parameter. N determines when recursion stops. So that's the reason I use n. Sum doesn't determine when recursion stops. Max doesn't determine. Depth doesn't determine when recursion stops. I use the parameter that determines when recursion stops. That's the reason I use n, to simplify it, yes.
Is there always only one parameter that stops recursion?
Not necessarily. You may have 2 parameters. You may have a 2 parameter and say when one is greater than the other, recursion stops. So we'll see some examples like that later.
Well, doesn't it have 4 arguments?
Yes, but I only consider the argument that stops the recursion to make it simple. Okay? So 5 will continue f4, f3, and 4 will be F3, F2, and this will be F3, F2, this will be F2, F1, 3 will be F2, F1. F1 will stop because the condition says if it is 1, it stops. And F2 will be F1, F0. So this will be F2, F1. I reach the bottom. The bottom means it doesn't call recursion anymore. It's either 0 or it is 1. So this is called a cold tree. Now this you have to make some imagination that this is called root. So this is a tree upside down. And these are called leaves. Leaves means the recursion stops. It no longer calls itself. Any questions so far? Yes?
So by looking at this, can you already find out what sum is?
Yeah.
Not yet.
Some.
Not yet. Not yet.
Not yet. Couldn't you like?
But we find depth. Sum need to add them together. Depth is, if you, let me go through depth first, then I talk about sum. Okay. Every time you go down, your depth increment by 1. Do you see that? And then you keep the largest one. So from here, if you look at line 28, your depth start with 1, right? The last argument, depth start with 1. So here, depth is 1 from here. You go down 1, becomes 2. You go down 1, becomes 3. And go down 1 becomes 4, 5, 6. So here depth is 6, here depth is 5. You keep the largest one. So when you go all the way down here, your depth becomes 6. So now we solve depth. Every time you go down 1, you increment depth by 1, and you keep the largest. That's what line 9 and line 11 does. You keep the largest. Are you with me so far? How to calculate depth?
Yes.
Any question about how to calculate depth? Okay, now talk about sum.
I have a question.
Yes.
Why do you do star max if star max less than def? Isn't it always gonna be less than def?
For this question, the answer is yes. But if you change the order of a 17 and 18, if you change the order, put 18 above 17, then this tree will be flipped. Does that make sense? Because if you do 18 first, you go 4 before you go 5. Right? So this tree will be symmetric. In that case, your depth will be smaller, then will be bigger. So you want to make sure. If you keep the order 17 and 18, depth will become 6, then you will never decrement. Does that answer the question? Okay, so how do you calculate sum? You count how many times f is called. So 1, 2, 3, 4, 5, 6. Okay, maybe I should make mark. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Did I miss any? Did anybody try this?
What'd you get?
Yeah,
You can copy, paste.
Do you get 25? Okay, I get 25, I count. Okay, now, you can do it in a different way. You can say, if I have F2, I know it is 3, including F2 itself. So I have 3 here. You don't have to count one by one. You can say, I count a few and start moving up. Does that make sense? So that reduces the chance of mistakes. So sum becomes 25. And the value here is going to be 1 and 1, right? Because line 13 says if 0 or 1, it returns 1. And then this add together, so this becomes 2. So F2 returns, in terms of value, it returns 2. So this gets 2. This gets 2. I probably should use another color. So this gets 2. 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 But F2 is 2. This is 1. So this becomes 3. F3 is 3. Because F2 is F1 plus F0. That's what the line 20 does, right? Line 19 does. Line 19 says you take the values and add them together. F1 is 1. Why? Because line 15 returns 1. And F0 is 1 because line 15 returns 1. You add them together, so F2 is 2. F1 is 1, so F3 is 3. 2 plus 1
Why do
is
you
3.
say F2? Okay, I got you. When you say F2, it's actually 1.
The value returned by F2 is 2.
Yeah.
So then you add it up. And that gives you the return value of FV.
What else questions do you have on the exam? I mean, because Q-sort, recursive tracing, what else could there be? Swapping?
Sure, swapping. Strings. What have we done in the assignment?
No.
Malloc. Free. Is that enough? Pointers, of course, everything is pointers. Almost everything, yes.
Can you show us what's the question on skin by? Can you move the
Are you-
exam?
Okay.
Are you going to ask about those?
This question, permutation, will not be in the exam.
No, just the question we just did. What's the value it's asking about?
What's value? I don't remember. I think sum is 25.
Yeah.
And value will be
It's 13.
13. So you get the, this will be 5, this will be 3, this will be 3, this will be 5, yours will be 8.
So we did not use depth at all, right?
No, depth is 6.
No, we did not use it to count the sum.
You do not use depth to count sum. If you look at the program, depth and sum, they don't
What are you?
affect each other, right? Depth and sum not. There's no place where depth and sum affect each other.
What is 89 and all those numbers in the bottom? I mean.
All those numbers in the bottom?
Yeah.
Or just give you, if in case,
How? Where
to
do we
help
get,
you.
Where do we get 89, 55? Where are they?
Okay, if you look at this, the number here, when n is 3, f3 is the sum of these two, right? 5 is the sum of these two. If you understand the program, right? If you look at line 819, says the sum is the sum of previous two. We try to give you some hint here. If you look at line 19,
so it's 13.
13, yeah, we didn't ask you for 13. We only asked you max and sum.
Max is 6, right?
Max is 6. We only asked you for max and sum. But we try to help you,
So to match it.
yes, to give you another way to check.
Is there a formula? I mean, that's you draw a table. I'm sure you just have a formula to.
Yeah, the formula is called Fibonacci number. So if it's called F1, F0 is 1, F1 is 1, Fn is Fn minus 1 plus Fn minus 2. That's the formula. And that is exactly what line 17 to 19 does, right? You call Fn minus 1 and you call Fn minus 2 and you add them together, then you return. That's this formula.
Yep.
Does that make any sense?
Yeah.
Yes, go ahead.
Okay, when you say explain how you found something, what are proper ways of explaining?
You can draw this.
Okay.
That I would say that's probably the standard way to do it. You have to explain, because if you don't explain, you just give a number. Where does it come from? Does that make any sense? Yes. And for this one, I would say when we grade it, you don't have to draw exactly the same thing. As long as you explain the concept, we'll be fine.
Okay.
Yes.
Can you go over the swap function from the last sentence, swapping two constant strings?
Okay. Swap string, actually we have that in the handout. Okay, swap, not Q sort. Okay. So if you want to swap, right? As I said before, you consider as a string. Why do I write this? Because remember I compared that with integer. I just say int1.
Some pointer to pointer.
Does this make any sense? Okay, so inside here I will say integer t equal to dereference int1 and right? And here I will say, instead of using integer, I will say string t equal to star str1.
Wait, when you say string in your arguments, is it string car star star?
It's car star, but let me first make a comparison between integer and string. Okay?
Okay.
Then I will say star str1 equal to star str2 and star str2 equal to t. Do you see the correspondence here? Okay. Now the only thing you need to do is to replace string by character star. Then you're done.
How about string t as well?
Yeah, replace string by character star. Do you see imagine you have a string type. Do you see these two functions are exactly the same, except you change integer to string? Does everybody see that?
Yes.
Okay. Then, since there's no string in C, it's character star. You just say string becomes character star. Then you're done. Yes. So let me just say, so this will become character star star. Yes.
So when you change the address of the two, when you swap addresses of two strings, you only swap the first address. First index 0 address of the string. So how come all the other addresses that come after that also change altogether so that they become continuous?
Okay, so string 1, in this case, string 1 is the address of the array.
Yes.
Right?
Yes.
That's why you have two stars.
Yes.
So you have an array. Let's say, actually it should be string 1 pointer.
Yeah.
So there is a maybe, okay. Let's say you have a string 1, and string 1 corresponds to the address of 20,000.
Okay.
What that means is at 20,000 you have a string. Let's say Purdue.
Okay.
Okay, you have a string 2, and let's say it's 55,000, you have another string. When you swap this. You make this 5,000, and you make this 2,000. You are not swapping the memory location, you are swapping the pointers.
But then the P is 2,000 U is 2001, how does all those 2001 also get swapped? I mean,
So when you call swap, remember when you call swap, you need to give address. You need to give address of str1 and give address str2. So I'm swapping this. Once you swap,
so it knows what is related to that. I mean,
you are swapping a variable here. The variable is an address. You are not swapping the data here. You are swapping the pointers.
I know.
So,
Oh, okay. I understand.
so
Good.
if we are just running the good, can we just do right int t
I got it.
int t equals to integer t equals to a string one and
No, different types. String one is character star. Character star cannot go to integer.
I'm trying to switch the address number, like,
Okay, you cannot use integer, period.
no.
You cannot use integer.
Is it-
Integer, character star are two different types. You cannot mix them.
Isn't string one just 2000 here? The address.
That's an address, but address is a star. You cannot mix types. So this one is will give you trouble.
It's a warning.
It will give warnings. Yes, or maybe error.
Does it matter what the and sign for the star one?
Say that again.
Does it matter what the
Of course, because you want to change the variable in a function inside the function.
Yeah, but the value of star one is the same, is the address of the first element.
You want to this one correspond to address here.
Yeah,
You have to give address, otherwise you cannot change the variable.
yeah, but the address of the star one, or the value of star one is the address. It's an
The
address.
variable of the star one is address. But you want to change this one, you cannot change that one. If you do this one, you are copying you are giving the address, you are giving this address, you are not giving this address. Does that make sense? You want to change this value, you have to give this address. Okay. I have a few more chocolate if you want to come over.